First, once again, full disclosure, I didn't buy this scope. It was sent to me by the Berkeley Nucleonics Corporation, short BNC, free of charge for, well, review. And review we shall their model P4025T. And if you haven't watched the unboxing video of that thing, card link, there I'll cover, weight, dimensions, screen size, viewing angle, how to switch this on and off again. So some basics I will not repeat in this review here. In this part 1 of the review, I will first cover the basic oscilloscope operation. So channel controls, vertical, horizontal, and trigger controls. And I don't expect any surprises here, but it's also a touch screen oscilloscope. So how is it? Doing all your settings via the traditional knobs and buttons versus using the touch screen. Is it really an advantage? Is it fun, or is it totally useless? Well, guess we will find out. Second, I will cover the performance spec of the scope. So we will play around, of course, with sampling rate. We will play around with the resolution. This is a 14-bit scope. And of course, memory depth, and have a look at the waveform capture rate as good as we can. So I guess at some point there will be, maybe in the future, a part 2 where I cover the more advanced functionality of that scope. It of course offers some FFT analysis and stuff, and we can play around with that too, but to keep that first part under 1 hour, I said, okay, just basic oscilloscope operation and performance data, which should be more than enough. So without further ado, let's dive in. And before I forget it, the unit I'm testing is at firmware version 1.3.0. Basic oscilloscope operation. So we will be talking about the trigger settings, horizontal settings, the vertical settings, of course the single channel settings, what's available there, and then maybe about a single trigger run stop, and leave all the other optional stuff that is not involved in the basic operations aside for now, with the exception of the Autoset button. And I'm feeding the oscilloscope here 4 different signals from my signal generator here for the review of that thing, card link. And we will simply start by pressing the Autoset button. The Autoset button is a little bit more prominent on other scopes, but it's simply an Autoset. So it now starts scanning what input signals come in here, and then automatically set the scope to display them in a reasonable manner. Then there are of course the channel buttons. To select a channel to apply the different settings, you simply press the button, and to switch a channel off while it is selected, simply push the button again. And now I killed the channel where the trigger is running, a bad idea. So let's switch that on again. You might have noticed if I switch off a channel, these buttons are backlighted, but the backlight for channel 2 is now off. It's not really visible at maybe in a dark room. I already raved about that in the unboxing video. So let's get channel 2 back online. A much better way to see which channels are active is here down in the display. And since this is a touch screen, you have the same functionality here, which is more intuitive. So I want to do channel 1 settings. I want to deactivate channel 1. There we are. I want to reactivate channel 1. And this is actually fun. Also in the unboxing I mentioned, I'm personally not a fan of touchscreens, but this is quite okay. And as soon as you select a channel, either via the touch screen or the channel select button, you get for that channel the basic input settings. So here we have for channel 1 coupling DC. Okay, that's the usual DC, AC and ground, and of course we want DC coupling for now. That's okay. Inverted on off, and the probe you are using. So the probe attenuation, this should go 1x probes and 10x probes. That's the usual you are using, but the range is quite extensive. 1000x probes. Okay, no, I want to 10x. And you see, I'm instinctively using the touch screen, but of course you can use the multi-purpose knob here to navigate the menus too. So if I go to 10x and just click here, it's 10x. Mesh curve. Are we measuring actually a current value? No, we don't. So I don't need to change that. Here you can then specify how many millivolts are an amp, or respectively how many amps are volt, if you have a current probe attached, that is. And the bandwidth limit, which is always handy if you measuring low frequency stuff. So that's the usual, almost every oscilloscope has it. 20 megahertz bandwidth limit, and you see how fast that updates. That's nice. So now at 20 megahertz bandwidth limit, of course, my 20 megahertz square wave is no longer a square wave. So let's stay with that. And you can do this, of course, for every channel. I'm just checking that the Autoset did everything correctly, and it did. Of course, you don't need to use the touch screen. You have also these buttons at the bottom and to the right of the screen. So if I want to get into my coupling, I can simply use buttons to change that, or my bandwidth limit, I can use the buttons. Important in that respect, because pressing here will basically do nothing. If you're just here in these menus, is the menu off button. So you get your real estate on the screen back. Moving on to the right, we have the vertical controls, position and scale. And you select the channel and you turn the knob and you can change the vertical position, and the oscilloscope changes into that thin line mode while you do it. It's not quite real time, there's a little lag, but still it's responsive enough. And of course, to do that for another channel, you select the channel either via by a knob or yeah, on the touch screen. And yeah, now I'm moving channel 1. And talking about touch screen, I can do this by just dragging the channel label here up and down. So yeah, and I don't need to select the channel explicitly to do that. I can do this for every channel individually without selecting it. Afterwards, it is selected. Other thing, yeah, we're on channel 2. Pressing the button will, of course, center the waveform. And you can also do the same on the touch screen. If you just touch it for a second, the label, waveform will be centered. And let's do that for all, because I like my waveform centered. So, nice. Besides the touchscreen stuff, the position control was box standard. So let's try the scale. I am on channel 1 and yeah, I can scale it here via the knob, no problem. What happens if I press the knob? Nothing much. I kinda hoped that I would get a Vernier function or something like that. Anyway, I should be able to do the same on the touch screen. So yeah, it says here position and position. So yeah, I can scale the whole thing just with a 2-finger gesture. Yep. A little more. No. Yeah. So if I want to scale on the touch screen the next waveform, I of course have to select it first, button or touch screen, and now I should be able to. Oh, it misunderstood my gesture. Oh. So yeah, let's go with the scale back a little to the original. Try that again. Yeah. So you can scale. It's easier to let one finger rest and just move the other finger. Okay, green, yeah, or red with the. That's nice, and the green. Too much. Yeah. I think I still would prefer to do that with the knob instead of the touch screen. But yeah, it's a question of taste. It's high time to move one step further to the right to the horizontal controls, and let's start at the bottom with the time scale. Yeah. Very responsive. Can you press that button? Anything happening? No, not really, but you can press it. Yeah, oh, that's nice enough. See all the waveforms. Yeah, my very nice sine wave, 20 megahertz, my square wave, 10 megahertz, and the reddish one here is the trigger output, and the greenish funny waveform here I just take something from the back from the TTL outputs of yeah, the signal generator. I already carded and linked it in the review of that one. Yeah, and of course you can do the same on the screen. That's not okay. I will use my left hand. Yeah, that's even working better than the vertical scaling. Okay. Well, moving on to the position relative to your, yeah, there's that little T for trigger symbol, the line. So we could actually, yeah. And you see there it's going again into that single line mode or thin line mode. It's quite responsive. Yeah, can't complain about that. Can scroll around here quite a bit. You have that overview bar, which is also almost standard at the top, and can center it again by just pressing the knob. Can we do that on the touch screen? Yes, of course we can. Can we center it? Maybe if I touch the trigger symbol directly? Yeah. Okay, that's it. So that's very, yeah, you have a label here for the vertical position. You touch it for a second or two and it centers. You press the trigger symbol on the screen for a second or two and it centers. Nice, consistent behavior. So at the vertical controls, I skipped the math button because I don't consider math really as a basic oscilloscope function. But I will talk about that horizontal button, which will split your screen into an, yeah, you still have the little bar here, but then you have another small overview window with the brackets that show you the area that is shown below in the bigger window. And of course you can now move around and you see in the overview window where you are, and you can change the zoom, yeah, making the window much smaller. And yeah, come on, now it scales. So yeah, you need a little bit of practice to really work that on the touch screen, but of course you can always use your knob to do the same. And of course you should be able to, well, let's try that. No, we cannot really scale the overview window. If I do the scaling motion here, the horizontal scaling motion, it will just, yeah, scale the window below. But anyway, if you have a large signal train, not of a repeating signal, but a more complex signal, that's a nice feature. And yeah, you switch it off by pressing horizontal again. And now my time scale is off. Let's correct that with the touch screen. Yeah, here we are. And finally, to the very right, we have the trigger controls. Yeah, it's also standard on each and every oscilloscope nowadays. Yeah, change trigger level. Yeah, no surprise here. Go out of signal range and oops, yeah, goes out of sync. Press the button and yeah, it centers. It centers not on 0 volt, but on 50% of the waveform. Whatever 50% of the waveform is by their definition. I mean, is that 50% RMS or is that 50% between peak to peak? Yeah, would have to do some experiments to determine that. On the touch screen, yeah, you have the trigger symbol. So yeah, you can simply drag and drop that. Yeah, drag it, not drop it. And of course, if I touch it for a second or two, yeah, it goes on the 50% of the signal line. So, yeah, also very consistent. The trigger menu, that button here, brings up a whole slew of options at the bottom row of buttons. First, we have the trigger type, and you have single, that means your usual analog triggers. You have a logic trigger, and you have bus triggers available: RS232, I2C, SPI, and CAN. I can't show you all the options in that video, so let's stay with the single triggers, where you have edge, video, pulse, slope, runt, windows. Looks nice, so let's select this by pressing the multi-purpose button. Okay, yeah. Let's go back to our classical edge trigger. And then for the selected trigger type, you have here the additional options for that type. Yeah, the source, of course, which is currently channel 1, but you can change that to channel 2, channel 3, channel 4, and AC, of course. Note that AC is obviously only available if you don't run that thing on battery, but have actually connected it to mains AC. So let's go back to channel 1. And as always, yeah, to get out of here, menu off. Next, we have the coupling options, which is currently DC, but you can change that to AC, which makes no difference, of course. We're feeding or triggering off a sine wave. And HF, which is a little bit a conundrum, because choosing the HF option, high frequency, it starts triggering only on the low frequency content of your signal. That's why the trigger now at a 20 megahertz sine wave doesn't trigger properly anymore. So let's get very quickly back to DC coupling. Okay. And then the slope, that's simple. It's only rising edge or falling edge. Yeah. And finally, auto and hold off. So you can have your trigger in auto mode, which means it will always display something normal. It will only display when you have actually had a trigger event. Single, yeah, you know that instead of triggering every time the trigger event happens, it only triggers at the first trigger event. Interestingly, yeah, we haven't talked about these buttons here. Every scope has it: run, stop, and single. But this is kind of duality. I mean, if I go here, oh, my menu disappeared. Yeah, auto time off. So if I go here to press that button, it changes the menu settings, of course. If I go to single, it changes the menu. So yeah, it's two possibilities to do that setting. Usually when using the scope, you will use the buttons here, of course, and my menu timed out again. Hold off, yeah, you can change that, of course, in the millisecond range, nanosecond range. Microsecond range, millisecond range, second range. Okay, we don't really need a hold off. yeah, it's nice when you want to have a trigger and only a certain time after that trigger event to record the waveform. Sensitivity might be a nice option because, yeah, maybe you have a very noisy signal and you really at an edge trigger want it only to trigger if the signal increases by a clear 1 volt or so and not by 100 millivolts. This is not in volts, but it is in divisions. So yeah, it automatically scales with your vertical setting, the scale. What was it? 0.3 divisions. Yeah, we have a clear sine wave, so I can put that probably down. No, doesn't go down below 0.3 divisions. And here I have the first minor bug. I mean, I'm clearly here in the sensitivity range. But if I press these buttons, I'm changing the time scale, the unit on my hold off time. But if I turn it, yeah, I change the sensitivity. So yeah, that's really the very first bug I'm seeing here. But yeah, anyway, let's get out of this menu, and of course, depending what trigger type you have chosen, the options will vary down here. And you can do all that stuff using the touchscreen too. So yeah, just select your basic trigger type, and what did we use? Yeah, Windows. Single, select your source. No problem at all. Coupling, yeah. Oh, looks, something must have changed because HF high frequency is working better now. I don't know what setting I changed. Anyway, we stay at DC, and slope, of course, yeah, there's only rising and falling slope. Auto hold off, yeah, the same. Normal, single, auto, and hold off. You can change the unit, decrease it and increase it. 10 microsecond, doesn't matter really. And sensitivity, well, it doesn't bring you up something on the touch screen, so yeah, you have to use the multi-purpose button, which is a bit inconsistent, but I guess that's the same flaw in the software somewhere deep below that lets you change the unit and scale of the hold off while you are adjusting sensitivity, and the multi-purpose button is, when you turn it, is actually changing the sensitivity, and yeah, on hold off you get the touch elements on the screen. Okay, so there's a little hold off sensitivity, something going on in the user interface which is not 100%. But well, no scope is without flaws. And yeah, that brings us to the last two buttons of basic oscilloscope operation. And we are currently stopped, and you can see that very nicely. The button is, the backlight is red. So if I go into run mode again, yeah, the usual picture we had all the time. And of course I can go into single operation. I automatically go into stop mode. And since I have a continuous signal, pressing single will give me a single shot of my signal. And yeah, to round it up, if you are in single mode, you can of course force a trigger. But I don't really have to do this with a continuous signal as that. And now what you have all waited for, performance. So you already see the scope is displaying here its sampling rate, its memory depth it's using, and the resolution. And yeah, waveform updates, I will mention that too, though I cannot really measure that or show that. We will have to believe the manufacturer on that number. Anyway, let's get started with performance. Let's talk about the sampling rate first, which is currently, with all 4 channels active, 500 megasamples per second. And to illustrate that a little bit better, I switch off the interpolation and go to dots. Okay, so yeah, for example, your yellow square wave here, this is a 10 megahertz square wave. So yeah, and if I switch off channel 2, nothing much happens. Channel 3, oh, we are up to 1 gigasamples per second with 2 channels active. I mean, 1 gigasample, it's advertised at 1 gigasamples, but usually on your budget scopes, yeah, this only works if you have just 1 channel active. As soon as you activate a second channel, the sampling rate will drop by half to, yeah, in our case, 500. And as soon as you activate a third channel on a 4-channel scope, it will half again down to 250 megasamples. Not in that case. You can have 2 channels active. Yeah, for example, channel 1 and channel 3. And still get the full sampling rate, which is nice. Some restrictions apply here. So you can have only 1 channel from that first group, channel 1, channel 2 active, and 1 channel from the second group, channel 3, channel 4 active, to get the full sampling rate at 8-bit resolution. Yeah, remember that. So that leads me to assume that there are actually 2 analog to digital converters in here. 1 for channel 1 and 2 and 1 for channel 3 and 4. But yeah, we would have to tear that thing down to verify that. Anyway, these sampling rates only apply for the 8-bit mode. So let's up the resolution. And you do that via the acquire menu. So yeah, performance mode 8-bit. So let's change that to, let's say, 12-bit. And yeah, I will not repeat everything using the touch screen in this section. You already seen how the touch screen works. Yeah, now we are down to 500 megasamples per second in 12-bit mode, 2 channels active. And yeah, it's basically the same. I mean, I can switch off channel 3 and it will stay at 500. As soon as I activate a third channel, we are going down to 250, and then we will stay at 250 even if we activate a 4th channel. So Nice. Let's try the 14-bit. Sorry. So, 14-bit resolution. Now at 4 channels we are down at 100 megasamples, and yeah, I can basically turn off all channels but one, and we stay at that 100 megasample, which is of course not very good for my 10 or 20 megahertz signal here, but yeah, just to illustrate what sampling rate you get depending on how much channel you use and what resolution. Let's go back to 8-bit resolution. Yeah, I'm using the touch screen this time. Yeah. And get down in the frequency to say 1 megahertz with that square wave. And adjust our time base accordingly. So what's the advantage of having higher resolutions like 12-bit or 14-bit available? Let me zoom in offline, of course, after I stopped the acquisition on that part of our signal. And I also zoomed in a little with the camera so you can see the dots more clearly. And yeah, and in the big picture we clearly saw there's something going on here in the rising edge, and it's not a perfect square wave, but if we really zoom in, a lot of that, yeah, if you're looking into the details, it's just digitalization noise. Because we have such a big signal, and if we zoom in at such a small portion of the signal here at the top, we only have, well, 1 or 2 bits resolution left when you're looking at it. And if you be honest, I mean, 8-bit resolution, your cheapest multimeters probably do 11-bit resolution, 2000 count, yeah, 3.5 digit. So resolution wise, the run-of-the-mill 8-bit oscilloscope are quite bad. Now let's do the same in 12-bit mode. Okay, I have to reset my parameters. I will do that offline, but yeah, you will be able to see it. Now our sampling rate has been halved, one channel 500 megasamples per second, as we are in 12-bit resolution mode. And now let's zoom in at the same part of the curve. Of course, there are only half the number of dots per time unit now, but this doesn't look like noise anymore. And if we switch on our interpolation, yeah, look how nice this ringing here looks now. So, yeah, that's the reason you would want a higher resolution. You're sampling a signal with a given amplitude, and then you want to zoom in into details that are very small compared to the total amplitude. You can do that, of course, by changing your position and your trigger settings when you are sampling, but then you will only sample, yeah, this part here, and you won't be able to zoom out and see the whole signal. You can, of course, increase the resolution further to 14 bits. Let's get the time scale here back to something reasonable. And yeah, to change the resolution, you have to be in run mode. And if we do that, something is happening. I mean, this is, yeah, even with higher resolution, it's not quite the same waveform, is it? And yeah, if you go to 14 bits and we now have a look at our channel parameters, it automatically activates the bandwidth limit. Because, yeah, at 14 bits, you're down at 100 megasamples, and then automatically setting the bandwidth limit to 20 megahertz kind of makes sense, but you have to be aware of that. We can manually go back to full bandwidth, and then we get something like that. So, yeah, 100 megasamples per second is maybe not enough for our 1 megahertz square wave. I mean, the frequency content of a 1 megahertz square wave is of course much, much higher than 1 megahertz. So, yeah, let's tune that down to something reasonable. So I'm down to a 100 kilohertz square wave, which looks very nice. As expected, we are still at 100 megasamples per second and 14-bit. And now let's stop that and I will zoom in if we can see some details here at the rising and falling edge. And indeed, we can. I mean, we are now here, 1 unit is, what is it? 50 millivolt as the 5 volt signal. So we are looking here at the range of 100th of the complete signal amplitude, and we still have a very nice resolution, and we see that it's not a perfect square wave. It does overshoot, but then without any oscillations it levels down. And this is also, I can go back to the dot display. This is also not necessarily digitalization noise here. Let's change the time scale. This seems like, some real noise in the signal. Let's go back to vector. Yeah. So the 14-bit mode is quite impressive, but it has its limitations. Basically, the bandwidth limit. Yeah, if I go to the channel settings of 20 megahertz, which is automatically set in the background by the scope as soon as you select 14-bit. But you have to be aware of that, and really using it without the bandwidth limit active doesn't make much sense. By the way, the degradation of the sampling rate you have in 8 and 12-bit mode, so 2 channels at the maximum sampling rate and then 3rd and 4th channel with half the sampling rate. You don't have that here. When you are in 14-bit mode. So in 14-bit mode you can use all 4 channels. Okay, that's 10 megahertz signals on the time scale. Yeah, just ignore them. Your sampling rate will stay always at 100 megasamples per second. So if I might bring up that digital multimeter analogy again, with 14-bit you basically have let's say 16,000 count multimeter, so 4.5 digit with a sampling rate of 100 megasamples per second. And with 12-bit, we talked about this GP 2000 count 3.5 digits multimeters, that would be 11 bits. So with 12 bits you are already ahead of them with sampling rates up to 500 megasamples. With Yeah, if you are using two channels two channels only in some combination, or otherwise 250 megasamples per second when you're using 3 or 4 channels. I'm back to our initial settings, and now let's talk about memory depth or length, how it's called here in the menu. And you have the options between 1K and 40 meg, and 40 meg is a whole lot. I mean, 4 channels, 40 meg. If I freeze that here, and now manipulate my position, I mean, you can scroll here basically forever. Yeah, look at the cursor in the overview bar. You can, for the example, scroll really forever. So you can really sample very long varying signals if you want to. And if I change the perf mode here, and I have to go into run mode again for that, back to 14 bits, which makes no sense for my signals now, I'm down to 20 meg samples, which is still a whole lot. And yeah, 40 meg is no longer available. And in 12-bit mode, also only 20 meg. But 20 meg is, I mean, meg samples is still plenty, at least for the things I'm doing. So yeah, again, watch the cursor here. It's basically not moving at all. This is, yeah. And finally, let's talk about the update rate. But first, let's go back here to 8-bit mode. Okay, and make sure no bandwidth limits are active. No, wonderful. It's advertised at 70,000 waveform updates per second. And if I just manipulate here the frequency of, and we are still at 20 megasamples memory depth, change the frequency of the sine wave. Yeah, now it's no longer in sync, of course, but if I go down, for example, to 5 megahertz, yeah, I mean, this is almost real time. So yeah, I can't say if this is really 70,000 waveform updates per second, but it's fast enough. Conclusion so far. The user interface for basic oscilloscope operations, so your channel controls, your vertical, horizontal, and trigger controls, run, stop, signal, force, and yeah, don't forget the Autoset. It's all very consistent and works like on any other scope. Surprising for me, the implementation of the same functions in the touch screen are also very consistent and easy to grasp. Yeah, there is no fiddling around. I'm still preferring for scaling operations the knobs, but everything else, like using the menu, I'm really got used to do that on the touch screen because it is more intuitive. There was a little hiccup, two things. There was one little hiccup, you remember, in the trigger menu with the hold off and the sensitivity stuff. as well in the touchscreen as in the multi-purpose button. Nothing that keeps you from using the scope, but yeah, we'll see if that might be fixed in a future firmware release. And of course, you don't have a Vernier function on the vertical scale. But who needs a Vernier if you can have a 12 and 14-bit mode? And that brings us to, yeah, performance. On paper, you got a 200 megahertz analog bandwidth scope with 1 gigasamples per second and 14-bit resolution maximum. Of course, some restrictions apply there, okay? But to my surprise, there were at least partly not as severe as one would think. For example, you still get in 8-bit mode your full 1 gigasamples as long as you use just 2 channels. So you have really in 8-bit a 2-channel scope with a full 200 megahertz 1 gigasamples. And as soon as you go to 3 or 4 channels, you still have 500 megasamples per second, again in 8-bit mode, which is sufficient for the 200 megahertz bandwidth, at least in theory, to the Nyquist theorem, okay? So yeah, 12-bit mode is also usable at least in 2 channels with 500 megasamples per second up to the full bandwidth of 200 megahertz. Only if you use 12-bit mode with 3 or 4 channels, yeah, you have to be a bit careful about 200 megahertz signals. Yeah, that's more suitable for yeah, 100 megahertz bandwidth. The 14-bit mode, okay. In 14-bit mode, yeah, there's no way around it. You should use that thing with the 20 megahertz bandwidth limits in on all channels. I mean, that's what the firmware automatically does for you. Yeah, it engages the the bandwidth limits on the channel, and yeah, I guess they always have seen there is a reason for it. So for 14-bit resolution, it really is downgraded to 20 megahertz. But yeah, all in all, that's a very respectable performance. And yeah, of course, I skipped over all the advanced functionality, what I call advanced, the math, the measurement, and yes, that thing has an FFT, of course, and it has an XY mode, which will be much fun to play with. But yeah, I will have to leave that to a part 2, which will come at some time. Yeah, I have a day job. And yeah, till then, bye.